Hi, everybody. Good afternoon. Thank you for joining us today. Really appreciate all of you who decided to line up and wait to learn more about streaming data. My name's Adi, and I manage the Kinesis data streams and video stream services at AWS. And today, we're going to be talking to you about the evolution of streaming data on AWS through the various Kinesis services. But at the same time, we're going to be spending a whole lot more time with the real star of the show. I'll be joined by Timothy Inge, who's the Vice President of Engineering at GoDaddy. And GoDaddy and Tim's team have been on this journey over the last several months on moving from a more legacy-oriented, store-forward, batch-oriented world into a continuous streaming, real-time architecture for a whole bunch of different use cases. And he'll be going in a lot of detail, kind of pragmatic lessons learned on the journey and the results so far. For my part, I'll be providing kind of an overview of real-time use cases. We've been on this journey of streaming data now for well north of 6 years. Actually, it was here in November 2013 when we launched the first Kinesis service. I was actually the product manager back then for the service. And since then, we've helped tens of thousands of customers across the world, over hundreds of thousands of different kinds of use cases. And hopefully what you'll learn, some of it is kind of the distillation of those experiences. Having said that, show of hands, how many of you today have a Kinesis-enabled, or even without Kinesis, a streaming data workflow in production? Okay, I would say about 40%. And how many of you are kind of on the more beginning stages of the journey where you're dabbling with it, have a POC or two, or just curious about what streaming data means? Show of hands, please. Got it. I would say about the same. So as you can appreciate, some of the challenges with these sessions is that you find customers on all ends of the spectrum. So we'll do our best. I will provide a more higher-level overview of the services and drill down into a few distinct, diverse use cases. And then Tim will come in to go much, much deeper. So just kind of a really quick context setting. Data in and of itself is not about streaming. Data exists, and it is up to us, up to customers, to drive them into a more streaming form to deliver those use cases for which time criticality of the decision is very, very important. So again, data in and of itself, it doesn't wish to be bashed or wish to be streamed. It is what we decide to do with it. But over time, what we have learned is that there is conceptually this kind of time value to the data. When businesses respond and react to certain kinds of data in real time, they tend to either drive more efficiencies, save costs, drive more revenue, engage customers, prevent attrition. You get the idea. And this kind of diagram, I think, kind of thematically captures, and this is by Mike Gualtieri, one of the VP of Research at Forrester. In more pragmatic terms, though, we kind of define the streaming data domain in the milliseconds to minutes window, if you will. Because whenever we talk about real time, we go, well, what is real time? And what's real time to you may be different than what it is real time for somebody else. But when we think about most use cases in the millisecond domain, these are typically those that we would call kind of messaging style use cases for communication between a variety of microservices. In the seconds domain is where a majority of the core log ingestion style use cases, customer experience logs, user experience logs, IT infrastructure logs, application logs, security logs, you name it. And that is the vast majority of streaming data that we see today across any set of customers. The other big set of use cases, although not quite the same volume, but arguably the same kind of importance, is change data capture use cases. We're seeing a lot more of those happen primarily because A, there's been an explosion in the kind of databases, and B, the reliability and cost of converting that data flow into a streaming model has made it far more easier and more accessible to do change data capture use cases than ever before. And in the minutes time frame is when you have all of this ingested data that is now being transformed, pre-processed, format converted, metadata decorated, so on and so forth, as it makes its way into a data lake of sorts or into any number of other data analytical stores and destinations from where other downstream processing is kicked off. There is a canonical streaming data flow that comprises of the following layers. And you look across any sort of use case, and I would bet top dollar that you will find conceptually components falling in these buckets. There's the source of data. This is the thing, the application, the piece of IT infrastructure that's going to generate the actual raw data that you care about. There is an ingestion mechanism, a software library, a toolkit, an SDK, an agent that is going to be responsible to reliably publish that data into a streaming storage system. Now, people always when we talk about streaming data, they go, well, is it storage? Is it a buffer? Is it a queue? And we get into all sorts of conversations. For the purpose of simplicity, it's a kind of a storage system. It reliably captures, durably stores, cares a lot about ordering, and allows multiple different applications to simultaneously and independently consume that stream and always play it back in the exact same order. That is really the hallmark of a streaming storage system. It has to be processed, so it has a stream processing counterpart. And there are a whole number of different frameworks, managed services that allow you to do this real-time or continuous stream processing. And then invariably, the streaming data is not discarded. After it has been transformed or processed in some shape or form, it'll find its way into a data lake. On AWS, S3 is by far the most common place where we see streaming data end up. But we also see data warehouses, NoSQL stores. We see things like Elasticsearch, and a variety of other places where customers decide for their use cases to get streaming data into. On AWS, for the last 6 years, we've built out a number of services that work together to enable a whole bunch of different use cases. As I was mentioning earlier, 6 years ago, at this very platform, we announced Amazon Kinesis Data Streams, developer-oriented streaming storage platform for developers to build and operate their own stream processing applications using any framework of their choice, targeting second or sub-second use cases. Kinesis Firehose aims to make it bonehead simple to load streaming data directly into specific AWS destinations like S3, Redshift, and Elasticsearch. And they work together. Data published into a Kinesis data stream can be firehosed away into S3, a pattern we see happen all the time. And the stream processing counterpart for the streaming services is Kinesis Data Analytics. This is available for customers to use in terms of expressing their business logic, both in SQL and in Java, and I'll give you a little overview a few minutes from now. The sources of data at hand are, as I mentioned, very, very diverse. So when you think about what use cases make sense for you, mobile app, website clickstream, security logs, metering, billing data, IoT sensor data, all of these are real-life examples of data that are streamed today and at reasonable scale. In terms of how do you get it to actually publish data into a stream endpoint, you've got options. So largely, there are a set of AWS libraries and toolkits, starting from the SDK, the Kinesis Producer Library, agents, so on and so forth. And there are also a variety of open source or third-party software that customers can build, install, and configure for their sources of data to emit it in a stream form. Also, a number of AWS services themselves publish their relevant data into Kinesis streams, so IoT Core, CloudWatch logs, events, and through the data migration service, change logs can also be shipped into a Kinesis stream as one of the targets. As I mentioned before, Kinesis data streams is kind of the storage layer that customers provision, set their capacity, and ingest data at very low cost and at high scale. The service has been around for 6 years, and at its core, it is a highly durable log-replicated file system that is fully multi-tenant, runs across 3 availability zones, and is what we would call a foundational service at AWS. Lots of other AWS services, for example, CloudWatch logs are built on top of Kinesis data stream. So that's how we think about the service in terms of how essential it is to the functioning of AWS, really, and I don't think that's an exaggeration. The purpose here, of course, is for developers to be able to build their own stream processing applications consuming from Kinesis streams. You could use Kinesis Data Analytics, you can use Lambda, you can use Spark Streaming, Flink running on EMR, or on self-managed infrastructure on AWS. There are two consumption models. One allows you to differing primarily in terms of dedicated throughput provided to the consumers and the read after write or put to get latency available. The standard consumers have on average about 200 millis of latency in terms of when the data is put, three-way replicated, durably stored, and made available to the consuming application. And then using the enhanced fan-out consumer type, that gets shrunk down to about 70 milliseconds on average. Firehose is a different service with its own APIs. And its purpose is to really provide customers with a zero admin, zero operator overhead way of loading the streaming data into destinations like S3, Redshift, and Elasticsearch. This is near real time. Why? It's working backwards from the destination, like S3 or Elasticsearch. And so it will buffer, compress, encrypt the data, and make sure that it does a world-class, reliable, durable writing of the data into those specific destinations. And that's configurable to a certain degree by customers themselves. It also, along the way, does some amount of data format conversion to shape the data such that an analytical process can run more efficiently. The key difference between the two, as I had mentioned earlier, is when developers want to build their own stream processing applications with sub-second latency, start with streams. If your use case is really just about getting the streaming data loaded into these specific destinations with a small degree of transformation, start with Firehose. When in doubt, you can always start with streams. Why? Because you can attach a Firehose to it and get the data into the destination of choice without any other extra legwork on your part. In the stream processing domain, just like with publishing, there are lots of options. The ones that we talk about here are with the Kinesis Data Analytics for SQL and Java, but you can use Lambda, with whom the integration has existed since Lambda launched way back when. And of course, all the key stream processing open source Apache frameworks that run on EMR or in any other form you wish to do so, also consume and can process the streaming data. So the SQL-oriented use cases are really about not having developers learn a brand new programming model or framework, and being able to express simple and complex application logic within the SQL construct. There are a whole bunch of different pre-built functions. That's one of the great advantages. It can be expressed succinctly and at reasonably fast performance, while lowering the bar to entry for someone who's trying to get started with streaming data. And over the years, we've also built pre-compiled machine learning functions that can be invoked as part of the Kinesis Data Analytics for SQL offering. Kinesis Data Analytics for Java was announced and launched last year this time, at last reInvent. And this is effectively fully managed Apache Flink. For those of you in the know, Flink is one of the more popular, robust, and sophisticated stream processing frameworks that exists today. Customers can build, create their own jar, and effectively upload it into the KDA for Java service, where the service is responsible for mapping the jar into parsing it, compiling it, mapping it down to the operator graph, running it across a distributed set of compute instances, managing kind of the reliable, scalable processing behind that. And of course, all the goodness of Flink is naturally inherited because that's the programming model that is being expressed here. Now, to kind of tie this all together, the source, the ingestion mechanisms, the stream storage, the processing layer, and the destination, you will note that as you start on your journey, or if you're deep in your journey, you want to explore new use cases, you will have these components to varying degrees. Let me kind of spend a minute talking to you about one use case. And this use case is from a leading provider of 3D design and engineering software delivered as a large-scale service to millions of users worldwide. This customer runs on AWS. The majority of this software as a service is run as numerous microservices, raw EC2, containerized service, as well as Lambda. All customer experience interactions are captured inside of the Kinesis data stream on the order of several terabytes a day. And as the data flows in real time, on the top part, you see how Firehose is actually a consumer for the Kinesis stream and emits that data into Elasticsearch. And now the customer has an operational view into what my customer experience looks like via Elasticsearch. All the data is compressed, batched, and then sent into S3, from where more business-oriented users can use something like Athena to query against that data. So they're still kind of in the minutes, maybe an hour time frame, which is pretty reasonable for a core business user without building a very complex ETL logic and a batch-oriented workflow. And then Kinesis Data Analytics on the bottom is also a consumer of the same Kinesis stream data, generating a variety of customer experience metrics, sums, percentiles, derived measures that are emitted into CloudWatch, from where they have their kind of monitoring hooked up. And this scales at very low cost, and they have near real-time or real-time access to their customer experience. Here's another very, very different example. This is an example of one of India's leading supply chain services company. And they have successfully filled close to 500 million orders across more than 50 million households in India. And this is about the moment a customer clicks on their virtual shopping cart, have that event be generated and tracked from when the actual physical item is in the fulfillment center to when it gets pushed onto a delivery truck, gets moved to a sortation center, from where a last mile provider picks that up and then delivers the package to the customer's doorstep. Each of those events is emitted through their set of services that are fully containerized and emitted into a Kinesis stream, from where they use a series of Lambda functions, not just to fan out those different business events to a whole number of other downstream systems, but they also have pre-processing or post-processing a little bit in this case, and have that put again into Elasticsearch for broader operational use cases. That's a lot of discrete event data that is being captured and processed in real time in Kinesis streams, a very different use case than your typical customer experience log ingestion of data. And then kind of a third and kind of the final use case, this one's just fun, for me at least. Now this is about a company who wants to show how data offers players, coaches, sporting team management, and fans a very different way to engage with sports. In this case, the company has a different take on imbuing existing sporting equipment, in this case, cricket, golf, and rugby balls, and fitting them with sensors that can track motion, velocity, direction, force, spin, and then that data is emitted in real time into a Kinesis stream, from where a few different actions are taken. Again, like before, you'll see this pattern emerging. Invariably, a large segment of the data is stored in S3, in this case via Firehose. In this case, Lambda is used to generate real-time metrics on that data that's emitted into a DynamoDB table, from where those metrics are then served up to the various constituents, teams, players, so on and so forth. So So it's kind of a fascinating use case, but this time in the IoT domain. So hopefully you have that was a whirlwind tour, but hopefully you have a sense for what streaming data is, how the different layers are organized, and some sense of the Kinesis services, the role they play, and how some customer use cases have been solved for. Now I'm going to hand over to Timothy Inge. As I mentioned, Tim is the VP of Engineering at GoDaddy, and he's going to go deep in terms of what a streaming data journey really looks like from a practitioner's approach.
Thank you. All right, well, it's good to be here this afternoon. Thank you so much for your time. Now, before we get started, I wanted to talk a little bit about what GoDaddy is doing, because that will set the context on why we invested in a streaming data platform. Now, most of you may know GoDaddy as a domains and hosting company, but over the last few years, we've been evolving our mission to empower entrepreneurs everywhere. As a result of this mission, we've expanded our product portfolio, unifying them under a single experience, which is designed around helping our small business customers be successful at what they do. Behind the scenes, all of our products and services and experiences generate a lot of data. So we broadly classify our data into 4 categories. The first is logs, and this is your typical application or service logs that's generated just by running your service or your products. The second is e-commerce data, which is the lifeblood for our company. This is data that describes what a customer has purchased. The third is interaction data, and this is data that describes how our customers are interacting with our website or with our merchandising experience or with our products. And the final category of data is product data. This is data such as DNS settings or website content that our customers have. So how do we process all of this data? And the reality is that we've been on a data platform evolution. We started probably where most of you started, which is we just issued queries against SQL databases. Sometimes we would load the data into Excel for visualization. That evolved into what we call big data, right? And so we deployed an on-premise Hadoop infrastructure, and then we copied the SQL data from SQL onto Hadoop, and we did our processing there using tools like Hive or Pig or Spark and so forth. We generally power things like analytics with these, but over time we started to power other types of workload, like marketing workloads. And so the question for us is, what's the next step in the data platform evolution? And so to kind of consider that, we kind of looked at the challenges that we kind of face as a business. And so there were 4 areas that we kind of thought about as we were trying to figure out, like, how do we evolve the data platform moving forward? The first is around service re-architecture. Some of our services were undergoing a change. They were changing from kind of SOAP-based services built on top of highly schematized SQL tables into very decoupled microservices, maybe built on key value stores like Dynamo. And so this presented a major challenge or a major change to the data platform. The second is slow and unreliable data processing. It often took days to process data in Hadoop, and oftentimes we didn't apply engineering rigor to our data processing, and so sometimes the data was unreliable and not trustworthy. The data platform was originally built for humans, and so we had a lot of ad hoc data processing, which is perfectly fine when an analyst is looking at the data, but it starts to show its cracks when you're trying to build product or customer experiences over ad hoc data processing. And the final challenge is that we just run into private data center limitations. So as a result of these challenges, and probably a few more, we formulated a few goals for the next stage of our evolution for the data platform. The first was we want to migrate to AWS. We want to take advantage of all of the services and capabilities that Adi mentioned, and we want to be able to use those things for ourselves. The second is that we want to think about data as a service, right? That is, how do we think about data built not just for humans, but what does it mean to build product and customer experiences on top of a data platform? And the third goal was to invest in low latency data processing. So why did we invest in that, or streaming or low latency data processing? Why did we invest in that? And why did GoDaddy invest in it? And why would you be interested in that? The reality for us is that we kind of thought about 3 different motivations that kind of caused us to invest in low latency data processing. The first is our business, right? As our business evolves and as our business grows, there is demand for richer and more timely data. In our analytic functions, we want to make better decisions with fresh and reliable data. And beyond our analytical functions, we want to power better customer touchpoints and customer experiences through the use of data. The second motivation is a technical motivation, right? As I mentioned, the change to microservices and to key value stores that were decoupled presents a major challenge. So what we do is we stream this data from these services into the data platform where we can combine all of this data. And this replaces the kind of SQL-based type aggregations that were typically done with stored procs on your service databases. And for us, this separation of reads and writes is really critical for transactional service performance. And the third motivation is really around machine learning, right? Batch and bulk data processing is very useful for training, but for inference, it often demands low latency data because inference is often used in scenarios that affect customers. And so you need low latency data to make low latency inferences. So what did we build? We organized our thoughts around a couple of workloads, or 3 workloads. Right? The first is we want to build a set of APIs for our products and tools to integrate with. These APIs would give these services access to the data that was processed by the data platform. And we wanted to make sure that the APIs were designed with the services and tools need in mind. And so the business logic was actually implemented in the data platform. This meant that we didn't have to push that business logic up to the transaction services or store procs in their databases, which was a huge win for us. The second workload was around data notification. And so services could also subscribe and get notification when data changes. And so you have 2 options. You can ask for data using APIs, or you can be notified about data changes with notifications. And our last workload was a low latency Tableau dashboard for analytics purposes. So how did we build this? So when we thought about the migration to AWS, we had decided that we were going to build our streaming data platform on the Kinesis family of products. Why did we choose Kinesis? There were 4 kind of reasons for it. The first is that a lot of customers use Kinesis, right? And so there's a lot of information and knowledge sharing out in the world, which is really important for us because we didn't know a lot, and we relied on a lot of learnings that were available. The second is that Kinesis is fully managed. We had a really hard time running our own Kafka infrastructure on-premise, and we kind of didn't want to do that again as we moved to AWS. The third is elastic scale, right? Again, we had a really hard time trying to implement elastic scale on our data center, and it's just something that we didn't want to have to deal with. And finally, as Adi mentioned, Kinesis has integrations with lots of different AWS services, and that will allow us to focus on the things that matter for our business and not on tinkering infrastructure glue connectivity. So our team was new to both stream processing and AWS when we started this journey. And so we had decided that we were going to build a streaming data platform on AWS for very simple new scenarios, and we were going to support the existing business on our existing data platform as is. This allowed us to kind of focus on something very simple and iterate very quickly to add features to the streaming platform without having to be worried about the complexities of our existing business. And so to work on the new streaming platform, we kind of thought about 3 phases to approach building the new streaming platform. Phase 1 was about learning. We had a lot to learn, and we kind of organized our learning into those 2 areas. We had to learn about AWS, and we had to learn about stream processing. So for stream processing, we evaluated a lot of different technologies, and we selected Apache Beam as our stream processing library. We liked Apache Beam because it can run on Spark, which is what we happen to have on our private data center, and it can run on Flink, which we knew at the time that Amazon was going to support via Kinesis Data Analytics for Java applications. We also like Beam because the programming model kind of made sense to us. And so we invested learning more about the programming model. We experimented with things like bounded streams, unbounded streams, all the different types of windows and triggers. And we kind of had to get deep to understand the programming model of Beam. And we were able to do this running on Spark. And so in that way, we could decouple our learning. For AWS, one of the things that we knew we wanted to do was we wanted to be able to operationalize the data platform. So what that meant was that starting with the new AWS account, we wanted to be able to, in a fully automated way, provision and deploy a data platform from scratch, right? And so we invested and we learned about technologies like CloudFormation and Helm charts to the point where we can fully provision a data platform. And we also invested in things like CI/CD, so that changes to business logic in the data platform would be treated in the same way as changes to business logic in a service, complete with blue-green deployments. We brought these things together by deploying Beam on Flink, on EKS, on Amazon, in a fully automated way. So that set the stage for phase 2, and this is kind of where we kind of got into the actual streaming workload. And so as I mentioned, we kind of kept it simple, and we identified a very simple end-to-end scenario that will allow us to test how to build a low-latency streaming data platform. We focused on the 3 workloads. We want to have an API integration, we want to have a notification integration, and we want to have a reporting Tableau integration. And we want to do this with an engineering excellence that is what you would expect from a service that is customer-facing. So how do we do it? So I'm going to go over, first of all, a high-level architecture, and then I'm going to walk through a specific streaming example. So the first thing that we focused on was what we call data ingress, which is how do you bring data from the various services into Kinesis data streams. As Adi mentioned, there's lots of different ways, but suffice to say, our goal here was to make it very easy for the rest of the business to bring their data into Kinesis. And we wanted to do it in a way that we had metrics and monitoring and schema validation so that we could detect errors as close to the source as possible. During our learning phase, we deployed, as I mentioned, we deployed Flink on EKS, and we knew that at some point we would migrate that over to Kinesis Data Analytics. The next thing we invested in was we built a set of libraries or SDK around Beam. And the idea here was that we knew in order to scale, we had to allow our developers to build business logic without having to worry about a lot of the complexities that come with distributed systems and streaming and metrics and monitoring and all of those things. And so we invested in things like libraries and SDKs and tools to allow our developers to build business logic in a very simple way. And then we did this with a simple integration with Aurora databases. And so we had an integration to Aurora database with an API stood up that allowed you to query events. And so our end-to-end data flow took events from Kinesis, ran it through Beam, and then wrote those events into Aurora as kind of like our first start. One of the next things that we did was we wanted to support replay and disaster recovery. And I'll talk about that a little bit more in the next slide. But what that meant was we want to set up Firehose, as Adi mentioned. We firehose all of the Kinesis events that came into S3. One of the consequences of this is that we actually started building our data lake with this because we registered those raw events into a central glue catalog. On the other end of the data platform, we invested in additional integrations. So beyond Aurora, we also integrate with DynamoDB, with SNS, and with S3 as well. And this formed another part of the data lake, which is the process data would be entered into the data lake and glue catalog. And so this is a high-level picture of what our data platform looks like. So I'm going to go into an example now. When you look at this, you might be like, well, why do we need all of this machinery if all we're going to do is take an event that comes into Kinesis and then write that event out to Aurora, right? The reality is that the complexity of streaming comes when you want to do operations or business logic that require memory. That is that you cannot produce a result simply by looking at the event that comes in, but you need something else. Maybe you need to know an event that happened, or maybe you need to wait for a future event to come before you can process this particular event. Services like Kinesis Data Analytics or Flink make this possible, and this is what we call stateful stream processing. So I'm going to go through a simple example of stateful stream processing, and a good example of stateful stream processing is aggregation. Right? So in our example, we're going to get orders from e-commerce, and we want to aggregate. That is, we want to count how many orders come through, and we want to emit, as a result, the count. So in this case, the thing that we need to remember, the state that we need to remember is what orders, how many orders have we seen so far, right? And so how does this work? So what we have done is we have a piece of technology that we call the data importer. The data importer has a very simple existence in life, and its job is to bring data from a streaming service like the e-commerce service into Kinesis. And like I said earlier, we want to do it in a way that's where we have metrics on it, where we can count and compare how many orders we're ingesting. And we want to make sure we do schema validation and whatnot so that we can detect errors as close to the source as possible. We also firehose all of these events into S3, as I mentioned. And so at this point, we now have data in Kinesis, and we have the order data in S3. This enters our primary business logic, the data platform that's built on Flink, via a piece of common code that we call the fuser. And the fuser is part of this SDK that we kind of built. The fuser's goal in life is to abstract the fact that we have archived events in S3 and kind of like real-time or live events coming into Kinesis from our business logic. And so what it does is it mashes these two things together to produce a unified event stream. Our business logic then processes this unified event stream. And so like I mentioned, in this case, the thing that we need to remember is how many orders have we seen before? And that's the memory. That's a piece of memory that we need to know. And so in a stateful processing data platform, we store this in Flink state. Now, if you're using Kinesis Data Analytics, Amazon manages this state for you, and you don't have to worry about it. But if you're deploying Flink yourself, you have to configure a state database. In our case, we use RocksDB as kind of like the state database for Flink. This means that you have to tune RocksDB appropriately for your workload, and it's a little bit of it's difficult. But either way, whether you use Kinesis Data Analytics or whether you use Flink with RocksDB, you have state which is stored inside the stateful platform. So as an order comes in through the fuser, the stateful transform executes. And in this case, the stateful transform executes by doing something that we call a combine operation. And what a combine operation does is it takes the state, and then it adds, in this case because we're doing counting, it adds 1 to the state, and then it sends that out to the end. I mentioned earlier we have several integrations, so we write the count to Aurora, whereby there's an API that you can query and ask for the count. We write the count to DynamoDB, where you can have a key value lookup for the count, and we write the count to SNS, where you can get notification when the order count changes. So at the end, this is kind of what we achieved. So we were able to build a single data platform, a streaming data platform with a very simple scenario, right? End-to-end latency from kind of when an event happened to when it was delivered to one of the destination endpoints. We measured about 15 seconds, although I've heard that recently we made some improvements to bring that down under about 500 milliseconds. But we've done all this with engineering excellence, right? And so we have unit testing, we have functional testing, we have integration testing, we have CI/CD, we have blue-green deployments, we have disaster recovery, we have the ability to rebuild and replay, we have monitoring, and all of these things are really important. I'm going to touch a little bit on disaster recovery and rebuild right now. As you saw in the previous slide, we wrote everything to S3, and one of the questions you may ask is like, why do we archive stuff, right? Like, why don't we just have a streaming data platform that just reads from Kinesis as time goes? And the reason for that is that we want the ability to be able to replay what's in the data platform with events from day 0. So why would you want to do that? There's a couple of reasons why we invested in this. The first is if business logic changes, right? If business logic changes, we want to be able to replay and re-execute the business logic on all of the data from day 0. Another reason is for disaster recovery. We might lose our Aurora database, and one of the ways we can recover the Aurora database is by simply rerunning the data platform with all of the events from day 0. A third reason for this is if you may want to add a new integration. For example, we might want to add Redshift integration. And when we do that, we might want to flow all of history into Redshift so that Redshift has all of the latest data as well. So about 6 to 8 weeks ago, we put this data platform, as I've described, into production and started taking production traffic for the first time. So the next thing we tackled is, okay, well, this is great for services that support streaming. But how do we support our existing workloads, services that are built on SQL? Right? We couldn't go to the business and say, well, you can't get streaming unless you re-architect all of your services to support streaming. We wanted to be able to support streaming in such a way that we could leverage the data platform that we just built and deployed, and we had a goal to be able to do it without changing the existing SQL-based services with no changes to them. So the way we did this was that we used a technology called change data capture, which Adi mentioned. Change data capture is a SQL feature, which is effectively a table of changes that you can read from if you run CDC agent, usually on a replicated database. Now, one of the gotchas with change data capture is that it operates at the SQL table level. So you get a change data capture stream for each table that you have. In our legacy system or in our existing kind of SQL-based workloads, our services were highly normalized. So what that meant was that a logical entity, like an order in this case, was typically represented by many SQL tables. And so as you stream from CDC, you have to do joins to them, which is one of the reasons why we invested in streaming joins in the data platform. So what does this look like? So all we had to do was we had to make a very simple change. We added a capability to the data importer to be able to read from a CDC table. And so what that meant was that we were able to take the CDC entries coming out of SQL in a very low latency way and bring that into Kinesis. At that point, for the data platform, it just all becomes data. It's just schema, right? And so we modified our business logic to account for not just the schema of the original new e-commerce service that we built, but also to account for the schema that's coming in from CDC. And now suddenly we have streaming, low latency data processing on existing workloads built on SQL Server. So I want to highlight some metrics for you. We're able to do all of this with the same kind of latency that we saw with an integration with a new service that supported fully streaming. In other words, there was no kind of like latency hit to using SQL Server CDC. We have about 1 billion records or so in our existing SQL databases, and we tested some throughput. So we were able to process all of those records in about 3 hours using 8 small-sized EC2 instances for our EKS. We've experimented with paying more money with larger instances, and we could get that down to about 30 minutes. Or we could pay less money and take much more time. But the point here is that we were able to have elastic scale for our data processing. We also were able to achieve 5 million writes per minute into Aurora, which is one of the endpoints that we had. For us, the most exciting thing, though, was the ability to stream data from existing workloads built on SQL Server onto Amazon and have low latency data processing over all of that data. So what's next for us? We have a lot of things that we need to do and that we want to do, but one of the things that we've been exploring along with the Amazon team is migrating our Flink cluster onto Kinesis Data Analytics. As I mentioned, it's hard to manage your own Flink cluster. You have to deal with tuning and RocksDB management and all of these types of things that we kind of don't really want to be in the business of, and so we're really excited about working with the Amazon team on this. So this is what our future architecture or what our desired architecture will look like. All right, so overall, this is our journey so far, right? Our journey isn't over. There's a lot more to be done. But so far what we have is we now have a stateful stream processing data platform, and we're able to use this to power all of the integrations that we desire. We can power our product experiences through an API. We can power notification type experiences, and we can power low latency analytic experiences. So there's a few things that we've learned through this journey, and I want to share with you a couple of these learnings. The first is that stateful streaming is a relatively new area, right? And so our approach we thought was a good approach, which was to learn stateful streaming in a very incremental, small way, right? One of the things that we learned is that actually there's some cost surprises for us. With batch data processing, typically, the kind of things that you log things like, well, which stage of the batch job have you finished, and did the batch job complete successfully end to end? With stateful streaming processing, we often had to add logs for every event that came in, right? And so now suddenly, the number of logs or the volume of our logging increased exponentially, which was something that we did not expect when we started on our journey. The second thing that I would describe is that scaling is very hard. Distributed scaling is a very hard task. Scaling Flink and scaling EKS, it's challenging. There's a lot of knobs to tweak. There's a lot of things that you have to do. And so it's been a challenge to kind of get the data platform stable, to be honest. And that's why we're looking forward to something like Kinesis Data Analytics, because we don't have to do that work. We can rely on Amazon to do that work for us. The thing is, a lot of things kind of work simply. You know, when you do like 5 to 10 transactions per second, and your Flink cluster is running really just on one node, a lot of things kind of work. But when you're pushing like tens of thousands of transactions per second, suddenly you have to worry about a lot of different things as you increase the number of nodes that you have to manage in EKS. You have to worry about logging and diagnostics and alerts, and how do you know what went wrong, and how do you know where it went wrong? And so that's some of the learnings that we have. And really, I think one of the last things is that debugging a streaming data platform, like a distributed data platform, it's really hard. And so we kind of organized the way we thought about how we debug along these two questions. The first is, how do you know something went wrong? In a batch process, that's kind of very simple, right? Like your Airflow job or your Uzi job, that either succeeded or it didn't succeed. But with stream processing, maybe one event didn't get processed, right? Maybe. But how do you know? How do you know that an event didn't get processed? So we had to invest a lot of monitoring and tools to be able to answer that question. The second question we have to answer is like, well, then how do you recover from that situation? Let's suppose that something went wrong. How do you recover from that? Again, in a batch job, you just kind of rerun your batch job. But in a streaming world, where you're actually affecting customer experience, that's not really an option for you. And so one of the things that we found is that, man, debugging and kind of like running the service is pretty hard. Partly, this is because our data platform is now used in customer-facing scenarios. And as a result of that, all of the things that we worry about when we're building services, like mean time to resolution and all of these things, they apply to the data platform. The final thing that I want to leave with is we learned a lot from last year when we were here at reInvent, and we've talked to a lot of different customers. Some of you may be in this room. We spent a lot of time just learning from what you guys were doing. And so that's a really important learning for us. And so to continue that tradition, I have with me today Jake Swenson, who's our architect, and Jason Mackay, who's our director of engineering. And they are more than happy to answer any questions that you may have about what we did or what we've done or why we did some of the things that we did. All right, cool. Thank you so much. I'm going to bring Adi back up to wrap up.
Thanks a lot, Tim. That was pragmatic, super detailed, and what I thought was a really kind of compelling story around the realities of moving to streaming data on AWS. So we have about 10 minutes and change, and we are very happy answering any questions that you may have. There are a couple of mics in the aisles over there. So in case you care to venture forth, please do and ask questions. If not, just shout them out. We'll repeat, and we'll take this. So it lights a little bit bright. Any questions that we can help you with?
Okay. First of all, congrats on the presentation.
Thank you. Go ahead, please.
May I ask you?
Yes, go ahead.
Okay. How many Kinesis streams do you use? It's one per service or one per event?
In our deployment that we put into production, we have one per service. And so in the case of e-commerce, there's about, I think, 6 or 7 services, and so there are 6 or 7 Kinesis streams, one for each of the services.
And for the legacy, did you use the Bayesian or anything like that for CDC or the DMC?
Yeah, so for legacy, we use CDC, and so there's one stream per table.
Okay. But which platform did you use for that?
Which platform?
Or tool or anything like that?
We just read the CDC tables ourselves. So we have that data importer piece of code, which just reads the CDC tables and then writes it to Kinesis using the Kinesis SDK.
Okay, thank you.
Yeah.
Any other questions?
Yeah. So how big was the team and how long did it take for you to complete phase 1 and 2?
So the question is, how big is the team and how long did it take to complete phase 1 and 2? I think that's a hard question because we started the journey with only a handful of people, right, in terms of the exploratory, which we probably started about 16 to 18 months ago. And then as we journeyed through that, we started adding more people on the team to work on the data platform. Because like I mentioned, we wanted to make sure we supported the existing business as is. And so the majority of the team was working. So on the data team, we probably have about 30 or 35 people. And we probably split it. We probably have about 8 people working on kind of like the core platform infrastructure now. And the rest of the team is working on business logic. Yeah. And it took us probably so we deployed into production about 8 months ago. And we set up our Amazon accounts for the first time after we signed the contract about a year, like I think it was about September of last year. So end to end was probably about 1 year. Yeah.
Can you talk specifically about the benefits you got from using theme over writing in natively, say, Flink or Java, and how that affects your ongoing maintenance of the product? Are you happy with that decision and what this is good for anyway?
Yeah, so the question is, are we happy with the selection for Beam? And I guess I would say that, well, we selected Beam because it provided a set of high-level abstractions for us. That was one of the reasons why. Another reason why was because it actually allowed us to deploy a Beam kind of pipeline on Spark and Flink, which was one of the other reasons why we want to use Beam. And so far, I think we've been pretty happy with Beam. It provides what we think to be the right set of models and mechanics to handle streaming, like stateful streaming. So we have the ability to manage windows, whether we use global windows or session windows or whatnot. And we can control the triggers for how we send events down. And so I think we've been pretty happy about our choice. You can talk to Jake and Jason a little bit more, details afterwards, yeah. Yeah, so the question was that on our on-premise, we use Kafka, and now Amazon is offering MSK, which is a managed Kafka service, and will we switch to Kafka? I don't think we have any plans to right now. We've already invested in Kinesis, and so I think it's been good for us. I will say, though, that the way we designed the data platform is such that, and because we are running in our private data center today on top of Spark, is that we could switch to Kafka as kind of like the data streaming storage solution if we needed to, but we don't have any plans to right now.
Questions here?
Oh, yeah.
Hi. Quick question about your streams. You mentioned you have a stream per table. Are you sharding those streams? And if you are, how are you dealing with any concurrency issues, ordering issues on those sharded streams?
So the question is, are we sharding our streams in Kinesis?
Yes.
And then how do we deal with ordering issues? Yes, we are sharding our streams on Kinesis. And in terms of dealing with ordering issues, I'm going to actually ask you to talk to Jake and Jason, who have dealt with those problems, to very low level detail.
I have one more question here.
Yeah.
So in one of your slides, you mentioned about like 500,000 or maybe 5 million Aurora writes per minute. Are you guys using the multi-master Aurora, or you still have like one single node of Aurora?
We have one single.
How did you achieve that?
We have one single Aurora. Yeah, yeah. And it was a big Aurora instance.
Got it.
Yeah.
Thank you.
Hey, so this may be a question for you, Aditya, but you mentioned, just earlier was mentioned Kafka. How does AWS think about, like, if you're just starting out now that there is a managed Kafka service, when would you use Kinesis versus when would you use
Really
Kafka?
good question, and something that we get all the time. If you've already used Kafka someplace, on-prem, even on AWS, there's lots of Kafka that runs on AWS, and you've built tooling functionality that uses kind of the Kafka ecosystem in a way, then we would want you to, do away with all the operating burden of managing Kafka clusters and brokers and Zookeeper and use MSK. Absolutely, because at that point your cost of learning, cost of training up your skills is pretty low because you've already done that. If you're looking for the easiest way to get started, scale, and at the lowest cost with the most AWS integration, so I'm talking IAM, right? I'm talking Lambda. I'm talking, CloudWatch logs emitting stuff into a stream. Then I would say start with Kinesis. So that's it. I think at the end of the day, it's our job to provide the right set of options to customers, and we'll continue doing that. Thank you.
I have a question. At which point you're joining those streams? You mentioned that you would pull data from different tables using CDC, and you mentioned that now you have to join them. Where is this joining happening?
Yeah, so in our case, the join happens inside Beam. And it depends on the business logic that we want to do. So there's roughly two types. There's kind of like what we would call like an inner join, right? Whereby you want to, let's say that you're just joining two. In our case, we're actually joining quite a bit more, but let's just say we're joining two streams. In the case we're doing like what we would call an inner join, as one event comes in, you would have to store that event in state and then wait for the second one to come in. And then when both are present, you then emit the result out of Beam and out of Flink. You could also do an outer join, whereby as one event comes in, you just write that to Aurora, for example. And then when the second event comes in, you can just do an upstart into Aurora to kind of fill out the nose, if that's the right terminology. And so it really depends on the business logic that you need to build and whether the business logic allows you to do an outer join, which will basically, you'll have lower latency on outer join, but you may have incomplete data, or you may have to wait for all of the events to come in before you can do an inner join type of business logic.
So do you have some kind of a time limit, a window, how long you wait, like 10 minutes or?
That's a great question, yeah. Today, okay, so I'm going to say things that they may correct me. Today, at least in the pipeline that we've deployed into production, we use a global window. And so we basically will wait indefinitely. And that's worked for us right now because the way we bring data in, we guarantee that the data, we have guaranteed data delivery, right? And the way we do that is we use kind of like a polling mechanism. And so we manage kind of like, where have we read from the source system? And then we basically ensure that we read all records from the source system. That's what we would do with CDC. That's what we do with CDC as well. You can imagine that if you can't guarantee data delivery, right? So maybe you're pushing data into Kinesis, and maybe sometimes you would have an error, and maybe sometimes data would get dropped. Then you may not want to select a business logic which requires you to receive all data before you write it. And so it kind of depends on your end-to-end flow, kind of like what your data quality or your data SLA is, as well as what your business logic demands.
Okay, thank you.
Okay.
So we've
and
got,
feel free to talk-
10 seconds.
Okay,
So
we
one
have
more
time.
question.
Yeah, okay.
You talked about the recovery, right? So you stored everything in the S3 and then you have to replay. What is the best practices you followed by storing data into S3 and the order in which it received and you replayed in the same order?
So that's a great question. So the question is like, in terms of storing data in S3, I think we use event time, right? Arrival time. Actually, I think you should talk to these guys for much more detailed things. They're going to be available afterwards, you know, and we have nothing to do after this session, so we'll be outside. If you have more questions, we're willing to chat for a while.
Yeah. One more question. Can you just very briefly, what is your CDC importer written in, and what service does that run on?
It's written in Python, and it runs on EKS.
Okay, awesome.
Yeah.
Thank you very much.
Cool.
Do you wanna-
Thank you so much.